Okay, so this one, we can make that square root of 4 times 5 times square root of 20 times I squared. Okay, so we can go ahead and separate those two. So you have square root of 4 times square root of 5 times square root of 2. Uh-oh, should have made that square root of 2. There we go. And we know that I squared is -1, so that's just times -1. Okay, so that leaves us with 2 for our square root of 4 times square root of 5 times square root of 2 times -1, so we can just really make this negative. Okay, so you're like 99% done, because for this one, remember square root of 5 times square root of 2, you can make that square root of 5 times 2, which is square root of 10. Okay, so that gives us -2 square root of 10. All right, any questions on that one? All right. Move that up a little bit. Okay, so let's say, for example, you wanted to multiply, say for problem A, 6 times 2 plus 9i. For B, let's say -5i times 4 minus 8i. Okay, so for A, if we have 6 times 2 plus 9i, we distribute that and multiply it just the same way you would if you had a variable. Okay, so 6 times 2 is 12, and 6 times 9 is 54. So plus 54i. Now for B, the only difference is now you're going to end up with an I squared. Okay, so you do everything you would if you had a variable, it's just that instead of with an x squared, you leave it as x squared. But if you get an I squared, you have to actually make that a -1. Okay, so -5i times 4 minus 8i. Go ahead and distribute that one. You end up with -5i times 4 is -20i. And -5 times -8 is actually positive 40i squared. Okay, so like I said, if it was an x, it would have just been x squared and you would have been all done. But here, you have to remember I squared is equal to -1. Okay, so that equals -20i plus 40 times -1. Okay, so that gives us -40. So -20i minus 40. But if you want it in complex form, just switch them around and make it -40 minus 20i. And that's your a plus bi form. All right, so any questions on that one? Okay. He wants to write in. I'll leave that up for a few more seconds. Okay. Okay, so let's say if you wanted to multiply, say for A, 2 plus 3i, 3 minus 2i. And let's say for B, negative 4 plus 2i, and 2 plus I. Okay. And let's say if we want to write your answer in complex form. All right, so for problem A, we just use the FOIL method. I'll just rewrite it. 2 plus 3i, 3 minus 2i, and we FOIL it out. So our first, 2 times 3 is 6. Your outer, 2 times negative 2i, is negative 4i. Your inner, 3i times 3, is 9i. And your last, 3 times negative 2, is negative 6i squared. Okay, we know that I squared equals negative 1. So this becomes 6 minus 4i plus 9i minus 6 times negative 1. Okay, so if we, I'll combine them on the last step. So 6 minus 4i plus 9i, negative 6 and negative 1 makes that plus 6. Okay. And now you just combine your reals and reals and imaginaries to imaginaries and make sure it's in the right form. So 6 plus 6 is 12. Negative 4 plus 9, well, negative 4 plus 9i is 5i. So it's in the A plus BI form. All right, and I'll give you a minute to start on B. Kind of separate that. Bless you. right, so for B, move that up a little bit. You have negative 4 plus 2i times 2 plus I. And of course, we're going to just FOIL that out. So negative 4 times 2 is negative 8. Your outer, negative 4 times I, is negative 4i. Your inner is 2i times 2, which is 4i. And your last, 2i times I, is 2i squared. The I squared is negative 1. It gives you negative 8 minus 4i plus 4i plus 2 times negative 1. Or you could have just made it negative 2 right there. Okay. So those two cancel each other out. So you're left with negative 8 minus 2, which is negative 10, which becomes negative 10 plus 0i. Okay. Always remember that a plus bi form. Okay. So this were a multiple choice test, and you put, because one of the options will be 10 and one of them will be negative, well, 10 plus 0i. So if you put 10, that would have been wrong. All right. Any questions on this one? All right. Okay, so he wants to writing. Nope. Okay, so let's say, for example, if you wanted to multiply square root of negative 80 times square root of negative 80. Okay. That one's pretty much the same. Okay, so if we wanted to do that one, we can make it square root of 80i, or 80 times I. Let me make that get a little bit of room there. Times square root of 80i. Okay, so you end up with square root of 80 times square root of 80 times I, which is just I squared. Okay, so for this one, square root of 80 and square root of 80, that's just square root of 80 squared, if you put them both underneath there, times negative 1. The square root and the square cancels out, so you end up with negative 80. All right. So if you notice, just like with the example we did with the square root of negative 4 and the square root of 9, where if you just multiplied them together, would have came out positive. For complex numbers, more times than not, they're going to come out to be negative. All right. So any questions on that one? All right. So, okay, I'll put that aside there. Okay. Okay, so now we're going to go into dividing complex numbers. Straighten that a bit. Okay? And in order to divide, we have to go back to the conjugates. So if you remember, let's say if you have 2 plus square root of 3 and 2 minus square root of 3 are conjugates. Okay, remember the sign just changes, they're just conjugates of each other. We apply that same rule here. So in general, if you have a plus bi and a minus bi, they're actually complex conjugates of each other. Uh-oh. Okay, so kind of the same general idea, just they put the word complex in front of it. Okay, so for example, 7 plus 4i and 7 minus 5i are complex conjugates. Okay, same terms, different sign.